Hello everyone, welcome back. In this video, we are going to do few questions of functions. First question you can see on my screen, the function is given to us as fx is equals to x square minus 6x plus 13. Domain of the function is also given to us. Its x is greater than equals to 3. So first part of the question says show that f may also be written in the form fx is equals to x minus 3 whole square plus 4. So the given function we have to express in this form. The given function is quadratic function. This function is quadratic function. So we can express this function x square minus 6x. We can express this function by completing the square method of quadratic equations. So we'll use here completing the square method. So how we will do this? First of all, this function, I'll just write this function as y. I have to see the standard form of quadratic function, although we haven't done quadratic function as of now, but I'll just give you the standard form. Standard form of quadratic function is equals to y is equals to ax square plus bx plus c. So this is the standard form. So here if you compare, you can see the form is same. So here a is 1. So 1x square minus 6x plus 13. So what we have to do in completing the square method? We have to do half of b. See here a is 1, b is negative 6 and c is 13. We have to do half of b. Only the number. So b is 6. Actually it is negative 6. So negative part we have to ignore, only positive part we have to take. We have to do half of 6. So half of 6 when I am doing, it is equals to 3. So 3 times 1 is 3. Now its square I have to do. So square of 3 is 9. So in this function, I have to add this number and subtract this number as well. So plus 9 minus 9. So basically we are adding 0 to this function. So 9 minus 9 is what? It's 0. So once again I'll repeat, in this method what we have to do, we have to take b. This is a standard form of quadratic function I have shown here. Y is equals to ax square plus bx plus c. Here b we have to take. We have to do half of b. So b is 6 here. So 6 half is 3. After doing its half, I have to do square. That number I have to add as well as subtract in the given function. Now we'll pair them up. So first one is 1x square minus 6x and positive 9. Positive, this is our first pair. Now plus 13 minus 9. So like this we have to do, always the positive part we have to pair them, these first two, x square term and x term. Now here what will happen, this is a minus b whole squares form. So here a is x or 1x means x only, minus, because here minus is there, b is 3. So a minus b whole square plus 13 minus 9 is 4. So why I can write fx only. Now how did we get? So here you can see, if you do whole square, x minus 3's whole square, if you do, this is x square minus 6x plus 9. A minus b whole square is equals to a square minus 2ab plus b square. Here a is x and b is 3. So when we are doing its square, a minus b whole square, will be getting same form. So we knew this form. The question was in this form. This form we just wrote in this way. Here we can see. So hence we got the required result. This is what we had to prove. We had to express the given function in this form. So here we can see we have successfully converted the given function into this form. Also you can Here make a note. I will do quadratic functions also, but as of now I haven't done. But you can just make a note. In quadratic functions, this form is known as standard form or traditional form. Standard form or traditional form. This form is known as vertex form. This form is known as vertex form. Now, first part of the question is done. Let's do the second part now, part B. So in part B, what we have to do, we have to find the inverse function. So whenever we have to find inverse function, we have to use the vertex form. So this is the vertex form which we have found. So it is fx I'm just going to write as y is equals to x minus 3 whole square plus 4. So this form we have to use while finding the inverse of quadratic functions. So standard form of quadratic function is fx is equals to ax square plus bx plus c. But we have to convert the given function into vertex form to find inverse function. Okay, let's find inverse, because for finding the inverse steps I have told you. First of all, fx we have to write equals to y. So I have done that. Second step states we have to find the value of x. So let's find x. So x we have to find by transposing the terms to other side. So first of all y. First of all y minus 4 will do, because this plus 4 positive 4 we will shift to other side, it will become negative 4 x minus 3 whole square. Now we'll shift whole square to other side. We'll shift whole square to other side. When we shift whole square to other side, it will become square root. It will become square root. So square root of y minus 4. So this side I am left with x minus 3. Now x minus 3, I have to find the value of x, so only x should be left on this side. So minus 3 also we have to shift to other side. So y minus 4, square root of y minus 4, negative 3 when we transpose, it will become here positive 3. So we got the value of x. So x is equals to square root of y minus 4 plus 3. This we have done. Second step is also done. First is also done. Now third step. In third step, I have to write x as f inverse x and y as x. So let's change it. So here at x place, I'm going to write as f inverse x, and at the place of y, I can write here x. So this is the inverse function. This is the inverse function. So we found the inverse function. I'll write it down. So inverse of function is f inverse is equals to square root of x minus 4 plus 3. Now we have to state the domain and range of f. We have to state domain and range of f. So let's do that. Domain of the function is already given to us. It's given to us. For f, domain is already given to us. This is equals to x is greater than equals to 3. Domain of the function is x is greater than equals to 3. Range we have to find. For range, we have to see the values of y, because this is the restricted domain. It's not all real numbers. Although we know in case of polynomials, quadratic form, this form is polynomial only. In case of polynomial, domain is all real numbers. But here, it's not all real numbers. It's restricted domain. So, for this domain, we have to find range. So, range of the function we have to find. Now, the function is this. We have to use vertex form. We have to use vertex form whenever we are checking the domain and range of the function. So, x minus 3 especially for range. So, x minus 3 whole square plus 4. So, this is y. Y is equals to x minus 3 whole square plus 4. Let's find what is the lowest possible value of y. The lowest possible value of x is 3, because it states x is greater than equals to 3. Apart from greater than, it is also equals to 3. Equality is also given to us, which means the lowest value of x is 3. Which means the lowest value of x is 3. When we substitute value of x as 3, we'll get y's value as 4. So which means the least value of y is equals to 4. Now if you substitute any other value, suppose now x is greater than equals to 3, so it can be 4 also. So 4, when I am substituting here, when I am substituting 4, so 4 minus 3 is 1, 1 square is 1, 1 plus 4 is equals to 5. If you substitute here now 5, so 2 square is 4, 4 plus 4 is 8. So it keeps on increasing. It keeps on increasing, like this we can check. So here we got to know that y is greater than equals to 4. Y is greater than equals to 4. The least possible value of y is 4 when we are substituting x as 3. So after 3, whichever value we are substituting, the value of y is greater than 4. So y, we found the range also. Now F inverse. So C part is done. Let's do part D. In part D, we have to find the range and domain of F inverse. See, whenever we are finding range and domain of F inverse, they will get interchanged. So domain, it will become range of F. So range of F was y is greater than equals to 4. Now this same thing is the domain of inverse function. So domain of inverse function is y is greater than equals to 4. Range of the inverse function is domain of the function. So x is greater than equals to 3. But only one thing you have to do, the domain and range, they will get interchanged. Only thing what you have to do here, in place of x and y, because for domain we always write x and for range we always write y. So this way we have to write. Once again I'll repeat, domain and range of the function, and if in its inverse, they interchange. What does it mean? Here function f(x), f is there, and here I have function f inverse. So its domain is the range of the inverse function. These two are same. And range of the function is same as the domain of f inverse. So that's what we have done. Only while writing here x and y, you have to write accordingly. So here we have completed this question. Let's do next question now. Next question you can see on my screen. So two functions are there. Functions are in tabular form. So function f and g are both defined in the interval. Defined in the interval means this is domain. In interval form it's given to us. We can also write it in the equation form also. So it is x is less than equals to 4 and it's greater than equals to -4. Both the forms are correct. And g is invertible, it's mentioned. So if g is invertible, its inverse also we can write. That later on we'll do. First of all, we'll see what we have to find here. Some of the values of the functions are given below. We have to find. So part A. Part A says find f of 1. So f of 1 we have to find. So how we can do this? See, this thing states we have to find f of fx. We have to state f of fx. So here x is equals to what? X is equals to 1. So it's very easy. We have to see the value of f of 1 from the table. So what is the value of f of 1? F of 1 means what? Here x value, if I am writing 1, so what I'll get? So I'll write here f of 1 is equals to 3, f of 3 is equals to 2, and f of 4 is equals to 1. How I did? So at place of x I have written the value of x. X is 1, 3 and 4. X is 1, 3 and 4. At place of x I have written the value of x. So here, from here I got f of 1 is what? 3. F of 3 is 2 and f of 4 is 1. What I have done, so no need of getting confused. I have two here sets, set x and set fx. So with 1, 3 and 4. Here I have 3, 2, 1. So 1 maps with 3, 3 maps with 2, 4 maps with 1. So that means while explaining functions, I have explained you how to write this. So f of 1 is 3, f of 3 is 2 and f of 4 is 1. From here also it's visible, clearly visible. Now f of 1's value is 3. So here inside the bracket I will substitute its value, it is 3. Now what is f of 3's value? So f of 3's value is equals to 2. F of 3's value is equals to 2. So we got the first part, f of 1. Now let's do second one. Part B we have to do. In part B, we have to find G inverse. We have to find G inverse of f of 4. This is what we have to find. That means G inverse of f4 I can write. G inverse of f4 we have to find. So let's see. First of all, we'll write the table of inverse. So for inverse function, I told you domain, this is G inverse. Domain and range they interchange. So this is x, this is y. Y means fx. So gx. So this we can write as y in case of function. So y I am writing. So here it will be interchange. So this is range, this is domain. So domain and range they will interchange. So this is 1, 3, 4. It's domain, this is domain. So that will get interchanged with range of the G inverse function. And the range of the G function now, it's the domain of G inverse. So 4, 1 and minus 3. Okay, so I have written the inverse function. So f of 4 we have done. F of 4 is equals to 1. So you can see 4's opposite is 1. So we can write here G inverse as it is and f of 4 is 1. So now what is G inverse 1? So G inverse 1 means opposite to 1 what is there? Opposite to 1 3 is there. So that means this is equals to 3. Opposite to 1 3 is there. So this is G inverse. This is G inverse function. So opposite to 1 3 is there. That means its value is 3. So second part also we have done. Now let's do part C. Let's do part C now. So in C part, it's given to us find the solution of the equation. Find the solution of the equation. So equation is given to us as f of g of x is equals to 1. This I can write as f of gx is equals to 1. F of gx is equals to 1 we can write here. Now here something that should come whose answer is 1. F of which thing is 1? F of which thing is 1? So here we can say f of 4 is 1 because 4 maps with 1. F of 4 is 1. So that means here f of 4 should come. But what is there? What is there? F of gx is there. Which implies gx is actually equals to what? Gx is equals to 4. It implies gx is equals to 4. Once again, I'll just repeat. Here it says f of gx is equals to 1. So we have to check from function f at which value f's value is equals to 1. And we got to know here f of 4 is 1. So that means gx. This should be equals to what? 4. Now gx at which thing it is equals to 4. So this gx at which value is mapping with 4. So here if we see, this is function g. For function g we have to see this function g. So if you see gx at which value of x it is 4, it is 1. So here I can write g of 1 is equals to 4. So you can see 1 is mapping with 4. That means x value is 1, which implies here the value of x is equals to 1. So here we have done C part also. Let's do part D of this question. Let's do part D of this question. In part D, we have to find G inverse of G. G inverse of G of 2. This is what we have to find. Always remember one thing. Same functions operation with the function itself. It is always equals to 1. 1 or identity you can say. If I do f of f inverse or f inverse of f or g of g inverse, so same functions operation with the function itself, like functions inverse and the function itself. If we are doing composition, so operation O is composition here. If we are doing the composition of the function with its inverse, so it is equals to 1. If we are doing composition of the function with its inverse, it is equals to 1. So 1 into 2 is equals to 2, which means the answer of part D is equals to 2. So here we have completed this question as well. Let's do next question. So next question you can see on my screen. So this question is similar to the first question we have done. So here function is given to us, fx is equals to 2x square minus 8x plus 1. Domain of the function is also given to us, x is less than equals to 2. So this is the domain given to us. So what is the first thing we have to find? The first thing which we have to find is f of 0. Composition we have to do here. So let's do first part. So this is f of 0. So this we can write as f of f0. So f0 means first of all we'll find with x. Then later on at next step we can substitute x with 0. F of x. So main function is f. So what is the function f here? 2x square minus 8x plus 1. But here you have to remember when we are doing composition. So this is a function we are taking, but in this function we have to plug in this. In this function we have to plug in this. That means wherever x is there, I have to write the function fx. So here I have x. So at this place I have to write the function fx. So this is 2x square minus 8. So there itself I'll write. So x is there. So at place of x I have to plug in function fx. So fx is 2x square minus 8x plus 1 minus 8. Again 8x is there. So at place of x I have to write fx, and fx is 2x square minus 8x plus 1 and again plus 1. Now let's write here wherever x is there, because f of 0 we have to find. 0. F of f0. So wherever x is there, let us write its value as 0. So 2 times 0 square minus 8 times 0 plus 1 minus 8 times 2 times 0 minus 8 times 0 plus 1 again plus 1. So anything when we multiply it with 0, so it is 0. So this is 0, this is 0. So 2 times 1. 2 times 1 minus, this will also get reduced to 0. So 2 times 0, 0, 0 minus 0, 0 plus 1. So 8 into 1 again plus 1. So what we'll get here, we'll get 2. 2 into 1 is 2 minus 8 plus 1. So 2 minus 8 here I am continuing. 2 minus 8 is minus 6. Minus 6 plus 1 is minus 5. So negative 5 we are getting our answer. So first part of the question is done. First part is the composition of f with itself. So we did this. Let's do second part. In second part we have to convert the function or express the function. Rather than conversion, it's expression. So we have to convert the function in this form. This form we did in the first question which we did. This form is known as vertex form. This form is known as vertex form. So in vertex form we have to express the given function. So that is very simple. So by completing square method we will do. By completing square method we are going to solve it. Completing square method. So let us do. So 2x square minus 8x plus 1. Now, as I have told you, this is quadratic function. Quadratic function means in this highest degree of the variable is 2. We will do quadratic function in detail also. As of now, in functions, I got a question. So, I am just doing it. But detailed explanation also I'm going to. Okay, so let's do this question now. Quadratic function standard form is this: fx is equals to ax square plus bx plus c. So the coefficient of x square is a. So here that means a is equals to 2. Coefficient of b, x is b, so negative 8. You just have to relate. And then c is a constant term, so c's value is equals to 1. In completing square method, what we have to do, we have to take b. This is the positive value of b. So 8 we have to take b. B's value is 8. So only 8 we have to take. So half of 8 we have to do. Half of b we have to do. So steps I am repeating. First of all, b we have to take. No, with only with the positive sign, no negative sign. If it is there here, it's negative, but only number we have to take. After this, after this half we have to do. So then we have to do square of half. So here square of half is 16. So I hope it's clear to you. First of all, b we have to take, then we have to do half of it. Whatever answer we are getting, it's a square we have to do. So that number we have to add and subtract in the given function. So 2x square minus 8x, 2x square minus 8x plus 1 plus 16 minus 16. Okay, here you just have to make a note. I just missed this point. So this is the standard form of quadratic equation. Here a should be equals to 1. A should be equals to 1. In completing square method, a should always be equals to 1. If it is not 1, if it is not 1, we have to make it 1. What we have to do? We have to make it 1. So how to make it 1? I'll just do it from starting, because at starting just I missed one thing and I'm just correcting this one. So we have to take 2 as common. We have to take 2 as common. So I'm taking 2 common. So here I'm getting now x square minus, if 2 I'm taking common, so this is 4x, and then here I'll get 1 by 2. What I'll get, because 2 I'm taking common. So when I'm taking common, if you again multiply, see, you can get the same thing. So you will get 2x square minus 8x plus 1. So 2 when we take out common, if you have any number at numerator and you don't have any common factor, like here 1 is there, so we'll just write that number in, we just write that number at the denominator. Like here 2 I have taken out, and so here 2 I am writing at the denominator. Now from here I will take the values of a, b and c. From here I have to take the values of a, b and c. So a is equals to 1. So coefficient of x square is 1 now. So it should always be 1 whenever we are doing completing the square method. So b is equals to now negative 4 and c is equals to 1 by 2. Now b negative 4 is there, so only positive 4 we have to take. We have to take 4, we have to do half of it. When I am doing its half, it's equals to 2. So I have to do square of 2, which is equals to 4. This 4 I have to add in this equation, as well as I have to subtract. So this 2 will be outside now. Here I am writing everything inside the bracket. So x square plus 4x plus 1 by 2 plus 4 minus 4. See from how I did half of the b. Half of b I have done. B is 4 here. So half of 4 is 2. So 2 square is 4. that number we have to add and subtract. So now what I have to do here, we can just simplify. So how to simplify? So this is 2. Now we have to pair. We have to pair them. So x square plus 4x. So x terms together plus positive term, which we wrote from our end. So x square plus 4x plus 4, remaining 2 together. So 1 by 2 minus 4 together. So pairing we have done. Now this part, if you see this part 2, then this is x plus 4x square plus 2. If you see it carefully, I'll just explain. It is x square plus 4x plus 4. How I can write it? I can write it as x whole square plus, here this is 2 whole square. This can be further written as 2 into 2 into x. So this is actually of this form: a square plus 2ab plus b square. A square plus 2 into a into b plus b square. So this is what? This is a plus b whole square. This is a plus b whole square. Normally you have to remember one thing. Here always x will come, x square is there, so x will be there always. So then third term you have to see. So here x I have, x square you just have to write x plus, it depends here whatever sign is there. Now I have plus here. In the previous part we had minus. Here I have plus. So plus only we have to write. In previous part we had minus, so we wrote minus. Now square root of this we have to write. So square root of 4 is 2. What you have to do? You have to write x, because square root of x square is x, and you have to write square root of this. So this is 2. So it's whole square. A plus b whole square. So outside 2 is there. Now this fraction also we can solve. We can simplify this thing by taking LCM. So we have to make denominators the same by multiplying this one with 2. So here I'll get 1 minus 8 by 2. 1 minus 8 by 2. Yes. So I'll just clear this side now. I'm going to, because I need here space. Okay. So fx is equals to, let's multiply this 2. This 2 will get multiplied. Okay, next step I'll do. So here I got x plus 2 whole square. There I'll get minus 7 by 2. So 1 minus 8 is negative 7 only. So negative 7. Now this 2 will multiply. So 2 will get multiplied by both. So 2 times x plus 2 whole square minus 2 times 7 by 2. So 2 and 2 will get cancelled over here. So what we are left with now? We are left with 2 times x square, 2 times x plus 2 whole square minus 7. So you can see this is the form in which we have to express the given function. So here a is, this is, I'll write here 2 times x plus 2 whole square minus 7. Here a is equals to 2, h is equals to, because here plus is there, here minus they have written. So that means here plus is there. In the given function we got plus. So when two plus signs are together, when two minus signs are together, minus into minus only. So it is like this. It's like this. I'll rewrite over here. It's like 2 times x minus minus 2 whole square minus 7. Or we can write plus minus 7. So from here we got the value of a is equals to 2, h is equals to minus 2, and k is equals to minus 7. So basically we have converted in this form. So let's do now the next part. Conversion we have done by using the method completing square. Now in C part we have to find the range of f. So domain we know. So function f is this. We'll use now for finding domain and range. Domain is already given. For finding range we will use vertex form only, which is 2 times x plus 2 whole square minus 7. We'll use this form. How we can use this form? We know this thing x is less than equals to 2. This is the domain. So least value. least value, greatest value here, because this is less than function. So greatest value of x, greatest value of x here is what? 2. Because x is less than 2, then x will be equals to all the values which are less than 2, maybe -1, maybe 1, maybe like -5, all negative values. So greatest value, if I substitute here, if I substitute the greatest value, that means 2, x is equals to 2. If here I am substituting, so 2 plus 2, 2 plus 2 is 4, 2 plus 2 is 4, 4 square minus 7. So 2 times 4 into 4, 16, minus 7. So 32 minus 7. So 32 minus 7, 12 minus 7 is 5. So 25. 25. So y is equals to 25 when x is equals to 2. If I take smaller value now, you will see now, if I take any smaller value, suppose I am taking x value 1. If I am taking x value 1, what will happen in this case? So fx is equals to 2 times 1 plus 2 is 3, 3 square minus 7. So 3 square is 9, 9 into 2 is 18 minus 7. If we do 18 minus 7 is 11. If we take another value, this is x value 3 I have taken. No, this I have taken x value 1. If I take 0 also, if I take 0, so this will become 2 times 0 plus 2 minus 7. So 2 times 2 minus 7. So here 2 into 2, 4. 4 minus 3, 4 minus 7 is minus 3. So you can see y's value also keeps on decreasing. Y's value keeps on decreasing. So here we can write what is the maximum value of y we got? 25. Maximum value of y we got 25. So we can write y is less than equals to 25. Domain is already given to us. X is less than equals to 2. Y is less than equals to 25. For only one thing you have to do, check for the value of y at x is equals to, at this greatest, like we did for x is equals to 2. At this whatever value of y you are getting, so function its range will be less than that particular value, less than equals to. But if it is greater than, then we have done the case of greater than also, the first question we did. Now find the inverse function. So inverse function we have to find. So for inverse function also this form we'll use. So I'll write first of all fx in y form. So fx is equals to y I am writing. So 2 times x plus 2 whole square minus 7. First of all 7 will shift to other side. Y plus 7 is equals to 2 times x plus 2 whole square. Now this 2 will shift to other side. Y plus 7 divided by 2 is equals to x plus 2 whole square. Now square will shift to other side. If square will shift to other side, it will become square root. Y plus 7 by 2. So I am left with here this side x plus 2. Now we have to shift 2 to other side. So this side only x will be left. I'll write this side. So x is equals to square root of y plus 7 by 2 plus 2. When we shift to other side, it will be changed to negative 2. So x I can write now. We have found the value of x. X can be written as f inverse x. And here y can be written as x now. X plus 7 by 2 minus 2. So this is the f inverse function. So f inverse we found. Now state the domain and range. So you just have to interchange. So here f functions domain. So I'll write here domain of f inverse and range of f inverse. So we interchange we have to do. So x is, so what is the range of this function? Less than equals to 25. So this will become domain here. X is less than equals to 25. What is the range? What is the domain of the function? Domain of the function is x is less than equals to 2. So this will become less than equals to 2. So domain and range will get interchanged. So this is the range of the function. Y is less than equals to 25, and this will become here domain of the inverse function. So x I have to write. Don't write y here, because domain set we write with x only. So we found the domain and range of the function F inverse also. So I hope you have enjoyed the video, you have understood the concept. If any questions you have, you can let me know. You can post your answers in the comments. You can post your doubts in the comments section. I'll be glad to help you. Thank you so much for watching the video. Please like, share and subscribe.